Okay, I'm going to be working the homework section R2, Algebra Essentials. Hopefully this will go pretty quick because this is a review of stuff that most of you are familiar with. So the first problem here says to write the following statement as an inequality. X is greater than 2. So all we need to do here is think about X using the inequality symbols. We have 4 inequality symbols that we can use. Greater than, less than, greater than or equal to, less than or equal to. So here we just want to say X is greater than 2. And that should be it. So just so we understand what's going on here, we're saying that if you had a number line, here's 2, X can be any number to the right of 2, anything over here. So we could sometimes we just shade this region, draw like an arrow like that. We're saying everything to the right of 2, but not equal to 2. So normally we put like an open circle here at 2 just to show that we're not including 2. But to write it with an inequality, it is this, and we move on. Oh, I need to put the answer in. X greater than 2. Check answer. Next question. Okay, X is less than 23. X is, now we can use these symbols down here, less than 23. Check. Okay, X is less than or equal to 70. So X must be less than or equal to 70. Check. All right, now on the next one, we pick which of these graphs represents X being greater than negative 11. So greater means to the right, and we do not want to include negative 11 because there's not a little bar underneath that symbol. So here they use something a little different. I told you a second ago that when we don't want to include, we put an open circle. And when we do include, you put a solid dot. Well, you can do it that way, or you can do it this way, where if you don't want to include negative 11, you do a parenthesis, and if you do want to include negative 11, you put a bracket. So here we don't want to include it. So since we don't want to include it, we are going to clear this out. We are going to pick this one here. All right, now, okay, good. Evaluate the given expression if X is negative 1 and Y is 1. So they give us this expression, 6x plus 6y over 5 plus y, and they want us to replace all our x's with negative 1 and our y's with 1s. So this becomes, let's see, x gets replaced with negative 1, so 6 times negative 1 plus 6 times positive 1, that's what y is, all divided by 5 plus y, but y is 1. So in the numerator, these two multiply together gives us negative 6. These two multiply together gives us positive 6. So we're adding 6 and we're dividing by 5 plus 1, which is 6. And at this point, we have to do everything in the numerator first. So negative 6 plus 6 is 0. And 0 divided by 6 is 0. Remember, you can have a 0 on the top, but you can't have a 0 on the bottom. So that just gives you 0. So all that for nothing. All right, next one. Determine the domain of the variable x in the given expression. All right, so we're given this expression 19 divided by x minus 24. And we're asked to find the domain of the variable x. So when we look at this expression, what we want to ask ourselves is there any value of x that I cannot plug in here that would cause this expression to have an issue? Well, the denominator, right? The whole denominator can't be 0, right? If it's 0, then we have division by 0, right? We have 19 over 0, which is not allowed. So if x, let's see, if x is 24, then we would get 24 minus 24 is equal to 0. That'd be a problem. So what we want to say here is, one way you could write this down is you say the denominator cannot be equal to 0, else we have a problem. Then you can add 24 to both sides of this, and then you get x cannot be equal to 24, and that would be our domain. Everything except 24. So the way we're going to do this, we're going to select A, we're going to say all values of x. Maybe I should talk about what this means. This set of braces here tells you that we have a set of numbers, and the set of numbers that we're looking at are all the values of x. Okay, all the x values that you can think of. This means such that, and this is the condition you have. Okay, so we're saying the set of all numbers x such that x can just not be equal to 24. If it's 24, we have a problem. So I just want to make sure you understand what this is called set notation. So type in 24 there, let me clear everything else out here and check the answer. Okay, let me see here. Hold on a second. Okay, the next problem is asking us to figure out what -5 squared is. Now, this may seem like a simple problem, but we need to make sure we understand what's going on here. We have -5 in parentheses squared. So when you square something, that means you're multiplying it times itself. So you're going to take -5 and you're going to multiply it times itself, -5. And when you multiply two negatives, you get a positive, so we get 25. Now, compare that to this expression, which I'm guessing will probably come up here soon. Compare that to this, -5 squared. These do not give you the same answer because this really means -1 times 5 squared. And if you do the order of operations, you must do the exponents before you do the multiplication. So you have to do the 5 squared first. So you have -1 times 25. And then the negative times positive gives you -25. So these give you two different answers, right? These are completely different. So for this problem, the answer is 25. Yep, okay, so this one, it's not exactly the same. Hold on, this one is 5 raised to the -2. Now, anytime you raise something to a negative power, like if you take any value x and raise it to a negative power, that is the same as taking that and doing 1 over that x to the positive power. So if you had like x to the -2, this is really 1 over x squared. Well, here we have 5 to the -2, which means 1 over 5 to the second power. And that means just 1 over 25. And we're not going to do it as a decimal. We're just going to type it as a fraction. And you can do a fraction down here, 1 over 25. Okay. Oh, yuck. Okay, that looks like a mess. We have -2 cubed. I should point out that I have not done any of these problems. Like I'm doing these for the first time, so we'll see how this all goes. We have all of that divided by 5 squared x to the 5th y to the 9th z cubed. All right, so we are being told to simplify the expression. So we want to make this look a little bit nicer. So notice that we don't have any addition or subtraction signs. Everything is implied multiplication. So this is being multiplied, that's being multiplied, that's being multiplied, that's being multiplied, that's being multiplied. Everything is multiplication. So the good thing about multiplication is that you can rearrange things. So let me start with the numerator. Is there anything I can do in the numerator? Let me start with the -2 cubed. So -2 cubed means -2 times -2 times -2. And if you do that, you should get -8. So that top left corner becomes -8. Okay, then I have x to the 7th. I'm gonna leave that. Now let's look at this right here. So to do that, I'm going to use a property that if you have two things being multiplied and you raise those to a power, now this only works if you have multiplication in here, then that just turns into x to the n times y to the n. So you can apply this power to both of the factors. So in what I can do here is I can apply the 4 to the y and the 4 to the z. So it's going to become y to the 4th, z to the 4th. And then over, let's see, I can do the 5 squared. 5 squared is 25. Then x to the 5th, y to the 9th, z to the 3rd. Okay, now what I'm going to do is I'm going to start doing division, but I'm going to do these two grouped together because those both have the same base of x. These both have the same base of y. These both have the same base of z. So now I'm going to be using another property that says if we have x to a power over x, the same base, to some different power, that this turns into x to the n minus m. So you take this power and subtract this power. So I'm going to do that for each of these three. And then out front, I'm just going to put -8 over 25 times, now this becomes x squared because 7 minus 5 is 2. This one, be careful, 4 take away 9 is -5. So I have y to the -5. And then here z to the 4th over z cubed. 4 minus 3 is 1. So we just get z to the first power, which is just z. Now, this is a correct answer, but it says here use positive exponents only. So it does not like the fact that this is a -5. So what I'm going to do now is I'm going to rewrite this as -8 with the x squared there. The y to the -5, I'm going to drop down as a y to the +5. And then I have the z, which is still up top. And then I have the 25 that was on the bottom here. We'll just join with the y to the 5th on the bottom. That should be the answer. Let's see. All right. I want a fraction here, so it's going to be -8. Move my thing, and then it's going to be x. If you use the little caret key above the 6 on the keyboard, this thing that raises things to powers. So let me get back here. X. Let's see. Raised to the 2nd, and then I'm going to use the right arrow on the keyboard to move to the right, and then put z. And then down arrow to move down, and then 25y raised to the 5th. Check that answer. Good job. All right, this next one, we've got some more stuff going on here. Some more properties we need to make sure we understand. Little subtle things that get us, right? So here's the original problem. Okay, first thing I'm going to do is I'm going to realize that I have a fraction raised to a negative power. So we have a property of exponents that says this: if you have a fraction raised to a negative power, you can rewrite that by flipping the fraction over and changing it to a positive power. So I'm going to change this to a +2, but it's going to require that I flip this over. So I'm going to put 8y to the -8 over 7x to the -5, and then all of that to the 2nd power. So what I did from here to here is a legal move. It's not the only thing you can do, but it's one thing you can do. The next thing I'm going to do is I'm going to realize that I have y to the -8, which means that it will move down. And then since I have x to the -5, that will move up. And also notice that the -8 and the -5 are only acting on the y and the x respectively. They have nothing to do with the 8 and the 7. We would have to have parentheses like this if it actually was impacting the 8, but we don't. So, all right, so my next line, I'm going to put the 8 still there. The x to the -5 on the bottom comes up as an x to the +5. The 7 stays on the bottom. The y to the -8 on top goes down to the bottom as y to the +8, and then we still have a squared. Okay, now we're going to use a property again that we had talked about that, well, I'll write it like this. If you have x over y, if you have a fraction to the nth power, then you can apply the power to the top and to the bottom separately. So what I'm going to do is I'm going to square everything I see here and then square everything I see here. And let me do that over here. So I'm going to get the top 8x to the 5th and square it. And then I'm going to take the bottom 7y to the 8th and square that. And then using the property that we used in the previous problem, because there is multiplication between these, I can square each one of those. So that means I can take the 8 and square it, and then I can take the x to the 5th and square it, and then on the bottom I'm going to do the same thing. I'm going to take the 7 and square it, and then I'm going to take the y to the 8th and square it. All right. Now, 8 squared and 7 squared are easy, but what about x to the 5th squared? So another property. If you have x to a power, and then you take all of that and raise that to another power, what you do is you multiply the powers. So you multiply these two numbers together. So let me do this. 8 squared is 8 times 8, that's 64. And then x to the 5th squared, I multiply 5 times 2, I get 10. So x to the 10 over, now 7 squared is 49. And then y to the 8th squared, I multiply 8 times 2, I get 16. So y to the 16. There we go. So let's try this answer in here. So it's 64 x to the 10th over 49 y to the 16th. All right, we got it. Next problem. Find the value of the expression if x is 3 and y is -7. So this is another problem where what we're doing is just evaluating an expression. So they give us this expression. One of the main mistakes students make with that expression is that they think that this is just equal to x plus y. And that is not correct. You are not allowed to take the square root of each of these individually because there's addition here. If there's an addition or subtraction, you cannot just split it up into 2 roots and just do each one. If there's multiplication, you can. So if you had this times y squared, then you could do the square root of each one, make it x times y. That's okay. So for us, we're going to replace x with 3. So this is going to be 3 squared plus -7. So -7 in parentheses squared. That will be equal to square root of, let's see, 3 squared is 9. And then -7 times -7 gives us 49. And 9 plus 49 is 58. So the answer should be the square root of 58. And they want us to type in the exact answer using a radical. So they don't want us to get the decimal answer there on the calculator. So I'm just going to do here the square root and then 58 and be done. All right, next question. What the heck? Write the given number in scientific notation. All right, so we have the number 353.6. And the way we do scientific notation is we always want to move the decimal point over so that that we have 1 digit to the left of the decimal place. So when we move this 2 places to the left, that means what we're going to do is we're going to write 3.536 times 10. And since we moved it two places to the left, anytime we move the decimal to the left, what happens is we're going to put the number of places we moved it here, but as a positive number. So 3.536 times 10 to the 2nd power. Now, if this has confused you in the past, it's really not that complicated. All we're saying here is that if you take the number 3.536 and multiply that times 10 squared, which is 100, when you multiply that by 100, it moves the decimal place 2 places to the right. And that gives you back the original number here, 353.6. So this is just a condensed way of writing it so that this out here with scientific notation, every time you write it, you're always going to have some number and then a decimal point. It's just an easier way to work with numbers when you start to have really, really big numbers and really, really small numbers. Okay, so let's see how they want me to write this, because I'm not sure. Let's see, 3.536, and I'm going to go say times 10. Oh, I forgot to put the 10. Times 10 raised to the 2nd. Let's see if it takes that. Yeah, I took it. Okay, good. All right, next question. Okay, write this one in scientific notation. So we have 0.015. So I'm going to move the decimal 2 places to the right, put it right there so that I get 1.5. And then I have to write times 10. And now I move 2 places to the right. So this time I'm going to go 2 here, but make it negative because I moved to the right. And again, if you want to understand what's happening here, it's saying take the number 1.5 and multiply that times 10 to the negative 2. That's really 1 over 10 squared. That means take 1.5 and multiply that times 1 over 100, which really means 1.5 divided by 100, which gives you 0.015. So again, I'm just trying to show you, like, what does this notation mean? Here we go. So I'm going to write 1.5 times 10 raised to the negative 2. There we go. What number am I on? How can you tell? Question 14. Okay. So write this one in scientific notation, 77,959. So our decimal point, it's implied that it's right here, even though it's not written. So I'm going to move this 1, 2, 3, 4 places to put it there. So 7.7959. I moved it 4 places to the left. So I'm going to go times 10 to the positive 4. Right now. 7.7959 times 10 raised to the 4th. There we go. Again, all right. 0.0, oops, come on. 0.0000, there's 3 zeros, 887. So I'm going to try and get the decimal point right between those 8s. So I've got to go 1, 2, 3, 4 places to the right. So 8.87 times 10 to the 4 places to the right means negative 4. So there we go. 8.87 times 10, oops, not 19, 10 raised to the negative 4. All right, this time they want us to do this a different way. They want us to convert this to regular notation. They give us the number in scientific. So I like to think of it this way. 10 to the 6th power is a really big number, right? You're doing 10 times 10 times 10 times 10. So this number is going to get bigger than what you see here. So that means we're going to take that decimal point and we're going to move it 6 places to the right. That would make it bigger. 1, 2, 3, 4, 5, 6. So that means I'm going to need a 0 here, 0 here, 0 here, 0 here. So this is going to be 1, 6, 9, 0, 0, 0, 0. So 1,690,000. I don't need the commas. It should take it without it. Let's see. Yeah, okay. Next one, the other way now, right? 7.653 times 10 to the negative 6. This time, 10 to the negative 6, I'm thinking that's really 1 over 10 to the 6. And that's a very small number, right? 1 divided by this really big number gives a small number. So this number needs to get small. Or I should say it is a very small number, which means the decimal is going to move 1, 2, 3, 4, 5, 6 places to the left. So I'm going to have point, let me see, 1, 2, 3, 4, 5. I have 5 zeros, 1, 2, 3, 4, 5, then 7, 6, 5, 3. So you don't have to put a 0 in front, but I will. 0.000007653. Clear this out. Write this as a decimal, another one of these, okay, 1.5 times 10 squared. Okay, this number should get bigger because this is positive, so it should be, move that decimal point 2 places to the right, 1, 2. That just gives you 150. Another one, okay. I'm gonna go a little faster here. I have a negative there. And so I'm going to move the decimal point 5 places to the left. So 5 places to the left should make 4 zeros appear to the left of the 2. 2, 3, 4, then the 2, 9. Oh, finally something different. Okay. Express the following statement as an equation involving the indicated variables. The area of a rectangle is the product of the length and its width. So if you have a rectangle If L is the length, I don't like the way that L is written. Normally I would do capital L. And the width, then the area is the length times the width. Okay, that would be the equation. So the area of the rectangle is given by, area is length times width right here, LW. Check it. Done. How many problems are there? 21. Oh, there's one more. Okay, clear. Okay, express the following statement as an equation. Same thing, the area of an equilateral triangle. Okay, so an equilateral triangle looks like this. You have a triangle, all the sides are the same length. That's what equilateral means, equal sides. So it says that the area of an equilateral triangle is the square root of 3 over 4 times the square of the length x of one side. So if this is x, that means that's x and that's x. The area is equal to the square root of 3 over 4 times the length of the side squared. That should be the formula for this. They're telling us that. We're not trying to figure that out. They're telling us what it is. To prove this is true requires a little more work, but we're just trying to make sure we can write the equation down so that it's multiplication, right, not addition. So there we go. All right. Am I done? I'm done. Okay, good. So that's it for that assignment. We'll do another video on the next one.